Hey guys, Mr. Kyle at Myers Mathematics. So today is September 21st. We've got three problems to do today. We've got x squared plus 8x plus 7 and x squared minus 8x plus 7 and x squared plus 8x plus 12. All right, those are our three problems for today. So again, if you're not familiar with the factoring series, we do three problems on odd number days and four problems on even numbered days. And I don't post anything on Sundays because that's the day of rest. So I observe that day of rest. Although I'm going to start a series after September's over, so in October, on I'm going to do like 2 videos a week. One during the week on mathematics, and then another video that will go out on Sunday that I'll schedule to be posted on Sunday, and that one will be for spiritual kind of topics on Christian theology and things like that. So stay tuned for that. So let's go ahead and dive in to these problems. And if you're not familiar with the factoring series just yet, you can check out a bunch of other factoring videos, all the different factorings where the middle number, in this case 8, goes anywhere from 1 to like 10. And then for the ending number, in this case 7 and 12, the ending number goes anywhere from negative 20 to 20 and everything in between. All integers, meaning positive or negative whole numbers. So that's the factoring series if you're not familiar. So let's go ahead and dive in. Let's dive into this first one here. X squared plus 8x plus 7. So x squared plus 8x plus 7. So here's what I want to do. I want to factor 7. Well, 7's prime, so the only two things that multiply to give you 7, as far as positive and negative whole numbers, integers. And by the way, whenever I say only, that's what I'm assuming here is integers. If you're not familiar with what exactly an integer is, I have a whole video on the number systems, pretty much all the number systems you've ever heard of and a few that you haven't. So go check that out. It's also on my website and of course on YouTube. But anyways, 1 and 7 are the only things that multiply to give me 7. Right? Now, if I make them both positive, I could make them both negative, but if I make them both positive, then if I add the factors, I get 1 plus 7 is 8, which is exactly what I want. So now all I have to do to finish the problem is put some x's in front of my numbers and some parentheses, and I'm done, just like that. So the next one is the same thing, except it has a minus 8x plus 7. Right? Let me just check to make sure I'm doing the right one. Yep. So same thing, right? 1 and 7. But now I need to make them negative to get negative 8. Well, all I have to do is throw a negative in front. If I throw a negative in front of both of them, then they still multiply to give me positive 7. So negative 1 times negative 7 is positive 7. But now if I add them up, negative 1 minus 7, which is the same thing as negative 1 plus negative 7, then I get negative 8 when I multiply, when I add. So there we go. And then for the last one, it was x squared plus 8x plus 12. X squared plus 8x plus 12. All right, so just two things to multiply to give you 12. 1 and 12 multiply to give you 12, but they don't add to 8. So let's try again. 2, right? 2 goes into 12. 2 goes in 6 times. 2 plus 6 is 8. Boom, there it is. Got it. Now, there's another couple factors that give you 12, right? 3 goes into 12 4 times, but 3 and 4 would give you 7, not 8. So that wouldn't be the factors that we would want to use. So you can just stop once you get the ones that you want. And you don't have to start with 1 in that number every time. I just do that because if you do it that way and you just go through all the numbers starting with 1, you go 1, 2, 3, 4, right? Only the numbers that go in evenly, of course. If you just go through all the numbers starting with 1, then eventually you'll get to something that works, unless it's unfactorable as far as integers go, which could happen. But anyway, so 2 and 6 work, right? If they're both positive. So there we go. Throw an x in front, throw an x in front, and we're done. All right, that's it for today, y'all.